Good morning, students. In the last video, we have seen about the data types, various data types available, how to declare a variable, and how the memory representation for each data type occurs. So, all these things we have discussed in the last video. So, in this video, we will move on to the last part of the chapter 9, that is Introduction to C++. So these are the discussion points which we are going to discuss in this video. So the first topic which we are going to discuss about is access modifier. So what are all the various access modifiers available based on the data types, and what is a reference. So how the reference variable can be declared. Next one is formatting output. So how to format the output. So based on the user need or for the better appearance, how to format the output. And the last two topic is expression and type conversion. So how to convert the data type, so both implicitly and explicitly. So how the data types can be converted. So these are the topics which we are going to discuss in this video. The first topic is access modifier. So from the name itself, it means that it is going to modify, or it is going to restrict. It is going to restrict the accessibility permission of a particular variable. So in case if you want to access a variable, so if it is declared based on this access modifier, means it is not possible to access a variable. So for example, for this they have used the const keyword, the constant keyword. The const is a keyword, const. Const is a keyword used to declare a constant. So in this, the const keyword will restrict the accessibility permission for any declared variable. So here you see the example. So const int num is equal to 100. So in this statement, the variable num with an initial value 100 it is declared. So even though the value of the num can be changed during the execution, in case the user tries to modify the definition as const int num is equal to 0, so the variable num becomes a constant now, and the value will remain 100 throughout the entire program, and it can never be changed during the execution. So in case instead of using const, it just declare int num is equal to 100, means the value can be easily changed. But since it is declared with the const keyword, even during the execution or at any time, the value 100 cannot be changed. So this is the concept of the access modifier. So now you see the example. So hash include iostream.h, and the using namespace, all the common terms and all the common statements are used. And you see const int num is equal to 0 is declared, and the next line they are printing the value of num, that is it just prints the value 100. And in the third line they are trying to increment the constant, that is num is equal to num plus 1. So now if they try to print after the increment, means automatically it shows an error, cannot modify the constant object. So in and also in Dev C++, it also shows the error as assignment of read only memory num. So num variable is declared as a read only memory. So the data cannot be modified. So this is the concept of the access modifier. And the next topic is references. So here reference means it is going to give some reference for a variable. So it is going to give a reference for a variable. It means an alternate name for a variable. So that is the reference, concept of reference. So here the declaration of reference provides an alias name. The alias name for a predefined or previously defined variable. So say for example, int a is equal to 100. So already the variable a is declared. So now they are going to declare an alternate name, that is alias name for the particular variable a. So for that purpose, this reference concept is introduced. So the declaration of a reference consists of the base type and an ampersand symbol. So these are the two common things needed for declaring the reference. So here you see the syntax. The type is the data type, and with the ampersand symbol you have to mention the reference variable, that is a new name alias name is equal to the original variable name. So this is how you have to declare the reference, and the reference variable is assigned the value of a previously declared variable. So you see the example here. So the same all the common statements are included, and in the main function you can able to see first the int num is declared. So now they are going to give an alias name for the num variable. So int ampersand temp, temporary variable they have given, that is ampersand temp is equal to num. So whenever they call the variable temp, it displays the value of the num variable. So the num is equal to 100 they have given. So it means that both the num variable holds the value 100 and also the temp variable also holds the value 100. So in the fourth line you see they are going to print the value of num is equal to, from the num variable they are fetching the result, and in the next line they are going to fetch the result from the temp variable. Both displays the same value. So for this is mainly used for swapping of variables or swapping of contents. So for that purpose this reference concept mainly works. So this is how the reference concept works. And next one is formatting the output. So now we are going to format the how the output appearance should be. So we are going to format the appearance of the output. So we can change based on the user needs, based on clear appearance or clear visibility or clear understanding of the output, we can format the output. So for that the formatting output is most important in the development of the output screen for easy reading and understanding. So for this manipulators are used to format the output of any C++ program. So here the manipulators are the predefined function specifically designed to use the insertion and extraction operators. So we have already seen the insertion and extraction in the starting of the lesson, that insertion operator is double less than and extraction operator is double greater than. So like that, in those operators these manipulators can be attached for the better formatting. So C++ offers several input and output manipulators for formatting. So commonly used manipulators here we have given as NDL is used to line feeder. It means that when you give NDL means it automatically creates a new line. The cursor move on to the next line. And set W. Set W is nothing but set the width of the field assigned for the particular output. It means the number of characters, number of spaces, like that. So it gives a clear appearance. And set precision and set F, these two manipulators will work for the floating point, that is the decimal values. So now let us see what are all the manipulators. So how these manipulators works. First one is the NDL, that is the end the line. So NDL is mainly used as a line feeder, we have already told in C++, and it can be used as an alternate to /n. So escape sequence, we have learned about escape sequences. So in that /n is mainly used to insert a new line. That is an alternate for this /n. So in other words, NDL inserts a new line and then makes the cursor to point to the beginning of the next line. So there is a difference between these two, that is NDL and /n. So NDL inserts a new line and clears the memory, that is the clears the buffer, whereas /n inserts only a new line. It doesn't clears the memory, it just insert a new line. That is the main difference between the NDL and the /n. And the next one is set W. Set W is told that we have a width of the field assigned for the particular output. Say for example, the field width which determines the minimum number of characters to be written in the output. So that is the main advantage of this set W. So all these we will see in detail with the example in the next slide. Now let us see an example for this formatting output. So first line is hash include IO stream. So in this library function, in this IO stream library function, we'll be having all the input output manipulation of functions, all the methods like cout, cin, all these will be stored in this library. So for that we are going to include this IO stream. And the next one you see IO manipulation, that is IO manip. So in this library it holds all this manipulator function, that is set w, set precision, set f. So all these manipulators, input output manipulators methods are stored in this IO manip library. So next is using namespace standard, and the main function starts here, and we are going to declare the float variable for the basic amount, calculating the getting the basic amount DA, HRA and PF tax, gross, net payable. So all these we are going to declare in a float variable, that is float data type. And for gathering the name we are going to use the character, and the length of the character will be maximum of 30. So now the user need to enter the basic pay, it stores in the basic. So for in cout it just displays in the screen, enter the basic pay. Once you type the basic pay and press enter, the value will be stored in the variable basic, that is with the help of this cin. And similarly the DA and HRA will be gathered. And the calculation part, that is the gross is equal to basic plus DA HRA. So all these calculation part, the PF tax and the net pay, all these will be calculated. Now we are going to print these output with the help of the manipulators. So first one is set W25. It means that it just gives 25 character space, that is a blank space. You can able to see the output. So rather starting from the first line, or starting of the line, it just the basic pay word moves after 25 spaces. So that is the main purpose for creating for giving this set W. And the set w10, you can able to see after the basic pay there will be a equal distance, the basic amount will be displayed after the 10 spaces. So this is how the set w, even the set precision. So in case if after the calculation if any decimal point occurs, if you want to avoid those decimal point means, we can easily remove or we can easily add the decimal values with the help of the set precision and set f. So with these manipulators, so this is how we can format the output, so how based on the user need. The next example we are going to see about the set precision and set f. So how the set precision and the set f works. So you see the example, the same IO stream, IO manip, all these header files, library files will be included. And in the main function the value HRA is declared in the float data type, that is 1200.123. So now you see in the output cout set precision they have given 5, and they are going to print the HRA. Now you see in the above code the given value is 1200.123 will be displayed in 5 digits including the fraction, including the decimal point. So the result must be totally 5 digits including the decimal point, that is the fraction part. That is, so the output will be 1200.1. so it also includes the fractional part, that is a decimal part, decimal point. And you see how the set f works. Say for example there are two types, that is in set f, that is fixed and scientific. So now first, in the first example you see the set f, that is they have given ios is the main function, in that the sub function, that is the fixed method is used, and they have given that is set precision 2, that is 0.1. It means that, so fixed means it is a constant. So they have given set precision 2 means, so 0.1 the output will be as 0.10, that is after the decimal point how many fraction part must be included, that they have given in the bracket within the set precision. So the 0.1 is printed as 0.10. That is the set F. Under that, the fixed method, the first method. The same is given in scientific. So now you see the same set precision 2 is given, the 0.1 is given. The output will be, that is, it means that 1 into 10 power minus 3. So 10 power minus 3. So that is written as 1.00. That is exponent. For exponent it is given e, small e, and for 10 power minus 3 it is given minus 001. That is 3 decimal places. So after calculating this, the result will be 0.1. So this is the exponent form, that is a scientific notation. So this type also can be used for printing the floating points. And the next topic which we are going to discuss is expressions. So what is an expression? So how this expression plays a role in the C++ program. So an expression, we can say it is a combination of operators, constants and variables, and all these are arranged as per the rules of C++. So that is the main thing. So even it is a combination of either operator and variable or operator and constant, whatever may be, all these combinations are arranged based on the rules of C++. And also it can also have a function call which returns some values. So all the function calls can also be used here. So functions we will be discussing in the upcoming chapters. So there you will be learning about the function call. So here we are just to for knowing that the expression can also hold a function call in the combination. So there are various types of expression available, and an expression may consist of one or more operand. So operand here in the sense, say for example a plus b. So here a and b are the operand. So there are two operand like that. So an expression may consist of one or more operand and even zero or more operators. So an expression may hold an operator or may not hold an operator. It is not compulsory to have all these three operators, constants or variables. So it may have or may not have, like that. And here there are 7 types of expression given. So here you can see in the tabular column. So first one is constant expression. So constant expression means it will have only constant value. The value will be directly given to the variable. So that is, here you see int num is a variable, equal to is a operator, 100 is a constant. So the definition is arrived. So combination of operators, variables and constant. So variable is a num here, equal to operator, 100 is a constant. It may have another expression also in the right hand side. So next you see integer expression. So it is a combination of integer and character values. It is not compulsory, and or variables also. It is not compulsory to have only values directly. It can have also a variable, another variable also, with simple arithmetic operations. So here you see sum is a variable, equal to is a operator. Again in the right hand side you see num1 is a variable and plus is a operator and num2. So it just calculates, it just add these two value and produce the result and saves the result in the sum variable, that is sum. Sum variable is which is in the left hand side. So which is a variable equal to the operator, and again an expression is used, that is num1 plus num2. And next example is average. Average is equal to sum divided by 5. So it is a combination of, again it is a combination of variable operators. And next one is float expression. So float expression nothing but the result will be in the decimal point, fractional part, and that will be stored in a variable. So combination of floating point values or variables with a simple arithmetic operator. So the result will be floating point, that is a decimal point with the decimal points. So here you see area is a variable, equal to is operator, again 3.14 is a constant. We are going to multiply r into r. So this floating result, point result, will be stored in the variable called area. And next one is relational expression. Now we are going to store a relational value, that is either true or false. It is going to check a condition and it is going to store the result, that is a boolean value, that is true or false, in a variable. So here the example you see, x greater than y. So if it is a true means, if it is x greater than y means the result will be stored as 1, and if it is false means the result will be stored as 0. The same, the second example is a plus b double equal to. There is a major difference between equal to and double equal to. Equal to just assign the value to a variable, whereas double equal to is will check the condition, will check both the left hand and the right hand. So that is the main difference between the equal to and double equal to. And next one is logical expression. So here the logical operators are used. So till now we have used about the arithmetic operators in the integer expression, float expression, and in relational expression we have used relational operators. Now here we are going to use logical operators, that is logical and, logical or, logical not. So this also stores the result as binary value, that is a boolean value, either true or false. So you see the example, it's going to check a greater than b, that is one set of condition, and we have used logical and. They again a set of condition, that is c double equal to 10. In case if both the conditions are true means the result will be true, and if we use or operator means if any one condition is true means the result will be true. So likewise this is the logical expression. And next one is bitwise expression. And bitwise expression is combination of values and variables with the bitwise operator. Bitwise operator we use insertion and extraction operator. Here you see x double greater than 3, that is the extraction operator, and a double less than 2, that is the insertion operator. So we use this operators we called as a bitwise operator. For each and every bitwise the value gets changed based on the value given there. And the last expression is the pointer expression. So here pointer refer, it means it is going to point something, it going to point some address of a variable. So that is the main meaning of this pointer expression. So pointer is a variable which holds the memory address of another variable, so or the same variable. So here you see int star, that is the asterisk symbol is used, that is the star symbol is used for identifying it is a pointer variable. So int star ptr means the address of the variable ptr is stored. So that is the pointer expression. So this is all about the concept called expression. And the next topic which we are going to see is type conversion. So the process of converting one fundamental data type into the another data type is called the type conversion. So we are going to convert the data type based on some format. So this is a tabular column, you see how the conversion will be. So for example, so here they have given mentioned as RHO is the right hand operand and LHO is the left hand operand. It means that say for example A plus B. So here A is the left hand operand, so it is left to the operator, and B is the right hand operand, that is which is right to the operator. So that is A plus B. Consider this example. So in case the vertical, the first column displays the left hand operand, that is the first say for example A. So in case if A belongs to these data type means character, short, int, I am talking about the first column, that is the vertical column. and the B represents the first row, the topmost row, the heading, the character short. So in case these are the combination, if both A and B are character means the result will be stored as integer. And in case A is a character and B is a short data type means the result will be int. So for the character short int, you can able to see the first 9 values, the 3 by 3 matrix, you can able to see the 3 by 3 columns, you can see all the values will be integer. So where it gets changed, so character, if it is A is a character means and B is a long means, the result will be stored as long, because long data type holds more memory space. The memory representation, the memory allocation is more for long data type when compared to character. So that is the main reason of storing the resultant value as a long. So like this, the type conversion happens. So in case of two data type is going to get combined means the data type which holds more memory spaces or more memory allocation, that data type will be considered as a resultant data type. So this is the small basic concept of this type conversion. The type conversion are of two types. One is implicit type conversion and another one is explicit. So implicit means automatically internally it understood that based on the maximum memory allocation, it automatically takes the resultant data type. So that's what we have seen, the tabular column, that is a tabular column which follows by the compiler for a implicit conversion. So you see the example, hash include IOStream using namespace std int main, the function start here. So first variable A is declared as int, that is value is 6, and second variable B, that is 3.14, that is declared as float. Now the result A plus B, the resultant data type will be as float, because the float has more memory allocation when compared to integer data type. So this is automatically it converts the resultant data type based on the maximum allocation memory spaces of the both the operands. And on the other hand, explicit conversion means explicitly we are going to insist the compiler to change, we are going to force the compiler to change the data type, whatever may be the rules or whatever may be internally it is defined. So we are going to force the compiler to change the data type explicitly. So you see the same example, hash include iostream.h, and using namespace std, and here the main function starts. You see the first variable f, that is where f is equal to 78.685, that is declared as a float data type. In the printing statement, we are giving that before the variable we are giving that int data type. So before giving int data type, it means that the variable f, the var f is to be changed automatically, is forced to change to the integer data type. So the result will be as 79, because after the 0.5 more than 0.5 or equal to 0.5, automatically it's rounded to the next integer. So 78.685 is returned, is stored as 79. So this is how we explicitly force the compiler to convert the data type. In the explicit type conversion, so it is very easy for the user to convert the data type based on the user need. But during the explicit conversion, in case if the user assign a value to a type with a greater range means, it doesn't cause any problem, it doesn't cause any change, and there won't be any reflection in the output or the change in the data type in the resultant value. But assigning a value of a larger type to a smaller type means, so in case example, the LHO, that is the left hand operand and the right hand operand, we have told that whichever has the higher memory allocation spaces means it automatically converts. So in case if you want to convert, say for example, a float value, to a integer. In the previous example we have seen, so float has more memory allocation, say for example 4 bytes, and whereas integer has only 2 bytes. So it means the memory spaces allocation is reduced. So in that case, there may be a chance of loss of precision values. The data values may get lost. So this is the major difficulty or disadvantages in explicit conversion while converting the larger data type to a smaller data type. So these are the three common difficulties type conversion here. Double to float, so loss of precision. So if the original value is out of the range for the largest target type, means the result becomes undefined. So float to int, so loss of fractional part, so the fractional part is reduced. So if the original value may be out of range for target type, means the result becomes undefined again. And when long to short, means the loss of data occurs. The entire data may be lost because the long has the more memory space allocation, whereas short data type has very less memory space allocation. So this is the major difficulties we will face while doing explicit conversion. So with this, the chapter 9 gets completed. So we have seen all the basic concepts of the C++, what are all the elementary concept, the basic elements which are required for a C++ program, how to construct a C++ program, the basic fundamentals we have seen, we have covered in the chapter 9, that is introduction to C++. So in the next chapter, that is chapter 10, we will move on to the flow of control. So how the control is can be moved from one block to another block. So all these things we will discuss in chapter 10, that is one of the part of the introduction to C++, that is flow of control. Thank you, students.